Hello, Dr. Chatterjee. Dr. Chatterjee. Okay. You can close your video for the time being. Hello, Mr. Das. Mr. Das, you can put off your video. I will also put off after the start. Hello, Wilson. Hello, Wilson.
Hello,
Hello, how are you?
I'm fine. Yourself?
I'm fine. You are in Singapore?
Yeah, I'm in Singapore. I saw
Okay.
you have an invitation, and
Yeah.
the topic looks great. So I
Yeah.
thought
Yeah.
I'd join.
Yeah. General topic. But if you are interested to talk on the caustic soda worldwide market and other things, you are also welcome in this lecture series.
I see. Okay. Okay.
Anybody in the team interested, please indicate the topic and we will keep them in the
Okay.
series.
As like a webinar right now. You mean?
Webinar, correct,
Okay.
correct. You have
Okay.
to send your recorded
Mm.
presentation and we encourage that one. Okay,
Oh, I see. So I record and send to you. You put it up.
I will put it up. We will give you time
Mm.
every Friday month, last Friday. Since tomorrow is our Republic Day, so this is is on today, on 25th
Ah,
January.
I see. I see. Okay. Okay. Good. Good.
Okay, so this another 4 minutes we'll start.
Okay.
So let me start. Please put off your camera and as well as your sound because another 3-4 minutes we will start our uh, presentation.
Okay. May I ask you a question right now?
Hello.
Oh, may I ask you a question now?
Yeah, not now.
Oh,
Just after this presentation. Hello, Takuo.
okay. Okay.
After the presentation, you will get half an hour for question and answers.
Okay. Okay.
Okay, then you can ask questions, any question on alumina, bauxite, alumina industry of India.
Okay. Good. Thank you.
Hello, ladies and gentlemen. In another 2 minutes, we will start our lecture series. We have resumed this lecture series, and the first presentation will be made by me. I am Ashok Nandi, and it will continue every month. There will be a presentation on the last Friday of every month. So this is our program, and this is the first presentation. And since it is the first presentation, I have started with my presentation. It is on general topic on bauxite, alumina industry worldwide and India, particularly with reference to India. So just at another 1 or 2 minutes, the recorded presentation will start. This will be about 40 minutes, 35 to 40 minutes presentation. Then it will be open for questions and answers. So you can put your questions and I will answer online. But the presentation will be recorded presentation. So I will just request another minute time, request our office to start the presentation. Priyanka, please go ahead
Yes,
with the presentation. Hello, good morning, good afternoon, good evening. This is IBAAS 2024 Technical Lecture Series. And this paper deals with bauxite alumina industry of India, some suggestions for development and improvement. I am Ashok Nandi, working for IBAAS, and I will be presenting this presentation today at the first lecture of IBAAS Technicals lecture series. So introduction, bauxite production. So at present, about 393 million tons of bauxite is produced in the world. And this is dominated by Australia, which is producing about 110 million ton per annum, and Guinea, which is the next country producing 105 million ton per annum. Although Australian bauxite is high in silica compared to Guinea, but thanks to developed infrastructure and geographical location, this country also exports raw ore apart from significant alumina production. Whereas in Guinea, there is not much of alumina production. So about alumina, about 130 million tons of alumina is produced in the world, and China is undoubtedly leader with more than 60% of bauxite production. Now you can see the bauxite reserves and production in the world. So as you can see in the bauxite production, Australia is number one with 110 million ton per annum, whereas Guinea is 105 million tons per annum at present. But reserves of bauxite is highest in Guinea in the world, and Australia comes second. China is having just 1 billion ton of bauxite resources, but it produces 60 million tons of bauxite per annum. And it's not a good quality bauxite. This is all mixed bohemitic diasporic bauxite. And then comes Brazil, which produces 35 million tons of bauxite per annum. And Indonesia and India both produces about 23 million tons of bauxite per annum. This is basically all metallurgical bauxite. And Jamaica with 7.7 million tons production, and Russia with 6.1 million ton of production. So basically, India in the bauxite production comes on the fifth position. Now, introduction alumina production. India distinctly occupies third position in alumina production with 9.8 million ton per annum during 2023. So India is distinctly in third position. Country has fairly good potential to increase the alumina production and surpass Australia by 2030. India has developed good expertise in alumina processing, and concerted efforts by R&D institutes and engineering companies may provide base for developing indigenous technology. There are already small operating alumina plants in the country built by Indian engineers. So you see the world alumina production in 2023, which is given in million tons. And number one is China, undoubtedly China. 79 million tons per annum alumina is produced in China. Australia produces 23 million tons of alumina per annum, but it may some of the alumina refinery may close down and the production may slightly go down in future. India is 9.8 million tons at present. And Brazil is 8 million ton, Ireland 4 million ton, USA 3.5 million ton, Russia 3 million ton, Jamaica 2.5, Greece 1.5 million ton, Indonesia 1.36 million ton, and Vietnam 500,000 tons. So this is the picture, overall picture in the world for alumina production. Now coming to the bauxite alumina industry of India. Bauxite alumina industry of India is undergoing rapid changes as several large bauxite deposits of Odisha state are allotted to Vedanta and Adani Group. Two greenfield alumina plants are announced in the state of Odisha. First one is Kalinga Alumina Plant Adani Group, which is planning to set up 4 million ton per annum alumina refinery. Second is announced by Hindalco, that is Aditya Alumina Refinery of 2 million tons per annum capacity at Kansariguda with Odisha Mining Corporation. It is time for the country to develop technological and engineering capabilities to build greenfield alumina refinery. Hello, here is the map of India which shows major bauxite deposit mines and alumina refineries of India. So as you can see, the major alumina refineries and bauxite mines are located in Orissa state in the eastern part of India. This is whole belt is known as Eastern Ghats bauxite belt. And this is having resources of about 2,360 million ton. So about 2.3 billion ton resources are here. So here, the oldest alumina plant was Nalco's Damanjodi Alumina Refinery. Then there is a Lanjigarh Alumina plant of Vedanta and the Utkal Alumina of Hindalco. And also in the adjoining state, there is Andhra Pradesh, there is the Enrak Alumina Refineries. So all the activities are confined in this belt, Eastern Ghats bauxite belt, which has a good quality gibbsitic bauxite, and all the activities are confined at present in this belt. Then you can see the central Indian part, which is our old alumina refineries are there. For example, Muri alumina plant of Hindalco and Renukut Alumina Refinery of Hindalco. And in the western side, there is only one refinery, that is Belgavi Alumina Plant or Belgaum Alumina Plant. This is also Hindalco Alumina Plant, and it is mainly for the special alumina production. And then you can see the Gujarat bauxite, which is basically used for refractory abrasive industry, and also bauxite was exported in the past, and now some bauxite is being sold to the alumina refineries. So this is the overall picture of India, and you can see the details of Eastern Ghats bauxite belt. Particularly, this is the boundary between the state of Odisha and Andhra Pradesh. And Odisha, you can see number of alumina plants, number of proposed alumina plants, and you can see in the Andhra Pradesh, the only alumina plant, that is Enrak Alumina Refinery, which is struggling for the bauxite, and most of the bauxite is imported from Guinea and Sierra Leone. So this is the overall picture of bauxite mines and alumina plants of India. Yes, so we come to the future bauxite forecast for India. The present metallurgical grade bauxite production in the country is likely to increase significantly with the starting of 3 new mines in Odisha, namely Sijimali, Kutrumali, and Balaga. It is expected that by 2030, India may produce about 59 million tons per annum bauxite, mainly from Odisha deposits. However, high-grade bauxite import may continue because it's a slow development. Except Odisha, bauxite production in other states may not increase significantly because these are all old deposits. It is unfortunate that large bauxite deposits of Andhra Pradesh are lying idle due to state government policy. To see the bauxite scenario of India, number one is the oldest mine of Odisha is the Pachpatmali Eastern Ghats. This is an Alco bauxite mines, which is having resources of 314 million ton and reserves of 340 million ton, and about 140 million ton is left over as the production has started in this mine in 1984-85 period. So this is the captive mine of Nalco, and present production is 7.5 million ton per annum. It may continue with the same thing. Overburden rejected and high silica bauxite not mined. So this is the main comments, and this should be avoided. And now they are getting a new bauxite deposit of 76 million ton, known as Potangi, and which may come into production shortly, maybe another year, and it may go up to 3 million ton by 2030. And then is the Baflimali bauxite mine of Hindalco, which is having 195 million tons of proved reserves, and leftover maybe 150 million ton because the mining is going on for last 5 years, 6 years. This is the captive mine of Utkal Alumina plant, which is presently producing 7.5 million ton per annum, but may go up to the 10 million ton plant will expand to 3 million ton per annum. This is one of the cheapest alumina plant in the world. And bauxite quality may slightly deteriorate. Now, next is the Kodingamali, which is given to Odisha Mining Corporation. It is having about 81 million tons of bauxite, and out of that, only 60 is left over. And this is presently producing 3 million ton per annum bauxite, and most of the bauxite is going to Vedanta Lanjigarh alumina plant. And the production may increase to 6 million ton per annum by 2030. And quality is continuously deteriorating. Next comes Kutrimali bauxite deposit, is about 127 million ton, and this is allotted to new alumina plant of Adani Group, which is known as Kalinga Alumina Limited. No production at present, but it's likely 1 year, 1.5 years, it will come into production and likely to increase to 9 million tons per annum. And Adani has ambitious plan to set up 4 million ton per annum alumina refinery in Odisha. Next comes Sijimali, which is allotted to Vedanta. This is having resources of about 311 million tons. And Adani and the Vedanta Group is seriously working on this deposit. All clearances are likely to come by the first half of this year, and production may start within this year. And this may increase to 6 million ton by 2030. So project development started, may take about 12 months for full operation. Next is Karlapat bauxite deposit, having 207 million ton resources. Auction process has been stopped for the time being, but a fresh auction likely to take place during this year. And this will most probably go to the OMC, Odisha Mining Corporation, which will be producing 6 million ton by 2030. Next comes Balada. It's a small deposit, 22 million ton about, and this is allotted to a KL of Adani Group, and which will come very fast in the production. And as early as third quarter of 2024, it is expected that this will produce bauxite, and part of the bauxite may go to alumina plant in Enrak alumina plant of Andhra Pradesh. Now there are many small mines of central and eastern and western India, which may have total resources of 650 million ton. Basically, Hindalco and Balco mines, some Balco mines are there, but these are all old bohemitic bauxite, small scattered mines of varying quality, and the present production may be around 5 million tons per annum, which may come down to 3 million tons by 2030 because it's not viable bauxite. Now comes Gujarat bauxite deposit, which is having about 100 million tons of ore in the Kutch and Jamnagar districts of Odisha. GMDC and others are mining. Gujarat Mineral Development Corporation and others are mining here. Present production is only 0.5 million ton per annum, but it may increase to 1.5 million ton per annum because there is a small alumina plant and there are some calcined bauxite production also going on in this state. Maharashtra bauxite is only 60 million ton, and the small mine owners are there. Present production is 0.2 million ton per annum, but it may increase, however, it may increase to 1 million ton. Basically, part of mostly metallurgical grade bauxite, and part of this thing is going to Belgavi Alumina Refinery of Hindalco. So it is expected that the present production of 23.7 million ton may go up to 59 million ton per annum by 2030, provided these bauxite deposits comes into stream. Now coming to the future alumina forecast for India. The present installed capacity of alumina in India is only 10 million ton per annum. Just compare, the China is producing 79 million ton per annum, but we are around 10 million ton per annum. We are distinctly in third position in the world However, there is an ambitious plan of Vedanta to increase the production to 5 and then 6 million ton per annum from the present 2 to 2.3 million ton after getting ore from the captive mine, that is Sijimali mine, which is having more than 311 million tons of bauxite. It is expected that by 2030, alumina production may go up to 23 million ton per annum, and India may catch up or supersede Australia. As one of the large Alcoa plant, Kwinana, may close down this year, which is having about 2.3 million ton per annum capacity. Vedanta may be the largest single location alumina plant in the country. Now, alumina scenario. Please see the alumina refinery. We'll first discuss about the Hindalco alumina plants. One of the oldest plant is Hindalco Muri, which is located in Jharkhand. It is having about 0.45 million ton per annum capacity, and the same capacity may continue. This was upgraded in 2008 and presently producing special alumina also. Then Hindalco Renukoot, one of the oldest alumina refinery of the country, is 0.7 million ton per annum capacity and may continue with the same capacity. Old integrated refinery with smelter and hence able to survive because there is an integrated whole process from bauxite up to the metal and downstream facilities. Hindalco Belgaum, Karnataka, is having 0.38 million ton per annum capacity and may continue with the same capacity and produce special alumina. And there is a shortage of bauxite, and time to time they import bauxite from Guinea and Sierra Leone. Hindalco Utkal Alumina plant, which is well-known plant in the world, one of the cheapest alumina refinery, and it is producing at 2.5 million ton per annum presently, alumina, which may go up to 3 million ton per annum in 2030. It's a modern plant, likely to expand in phases, lowest cost alumina refinery in the world. Now comes the oldest alumina plant of Odisha, that is Nalco Damanjodi, Odisha. This is a public sector alumina refinery. There is a 2.3 million ton present installed capacity, which may go to 3.3 million ton per annum. Expansion will be there with Potangi bauxite, and maybe another year or two, they will go for expansion project will start. Now come the Vedanta Alumina Refinery, Lanjigarh Alumina Plant, which is presently producing about 2.3 million ton bauxite per annum. And this is determined to go to 6 million ton, and it is feasible, looks feasible now because they have got the Sijimali bauxite deposit. So supply of Sijimali to start, augmented by OMC purchase. They can purchase bauxite also from OMC as they are doing it, Kodingawali bauxite. Now, Gujarat Credo, a small alumina plant of 0.04 million ton per annum, may go up to 0.1 million ton. They only produce special alumina hydrates. NRAC, as you know the story of NRAC, this is the only alumina plant in the state of Andhra Pradesh, which is having about resources of 600 million ton or 700 million ton. But the state government has put a ban on bauxite mining, and this plant is completely dependent on bauxite import at present. And this may go up to 3 million ton per annum. There is a possibility that they may get bauxite from Odisha, and partly they may import bauxite. So this is mainly based on the purchase of bauxite, and it started with at present with 0.7 million ton per annum capacity, mainly based on imported bauxite. Then come the ambitious plan of Adani, that is Kalinga Alumina Limited. They have presently no production, but the work is going on at site, and they may go up to the 4 million ton per annum by 2030. Project development initiated, and this is in planning phase, and at present the feasibility and other reports are being prepared, but they have already site selected, and the work may start within 6 months at the site. Now there is a joint announced recently joint Hindalco OMC plant, Aditya Alumina Refinery, which is having already site at Kansari Guda, In Odisha, no production at present, but they have a plan to produce 2 million ton bauxite per annum from 2028 or 29, and by 2030 it may have 2 million ton per annum. OMC may acquire 2-3 new bauxite deposits of Odisha other than Kodingamali. Kodingamali is already there with OMC, and they may get Karla part and some other deposit. And last is Mark Kundargi alumina plant of Chhattisgarh, which they have made a small alumina plant of 14,000 tons per annum, but the actual plant may come up shortly, and this will have a capacity of 225,000 tons per annum. And it is in feasibility stage, and this will use the mixed giepsitic biomimetic bauxite of central India, and it is all being built by Indian engineers. Now come some observations bauxite mining in India. These are my observations. This is in general, and this may be interesting for some of the audience. Despite having more than 3 billion tons of bauxite resources, quite a big bauxite resources. Reserves are although low, but resources are quite high. India is struggling to mine 24 million tons, and country has to import ore from Guinea and Sierra Leone. The fluctuating bauxite quality and processing of different types of ore causes loss in productivity in refinery. And it is better to process consistent low alumina and medium to high silica ore. This is particularly the problem in Vedanta alumina plant, which imports also, which purchases local bauxite also. So this has some issues with the fluctuating quality. Now, with the hope that with the CG Mali bauxite deposit, they may get a consistent grade in long term. Some of the large bauxite mines of Odisha, particularly the Pachpadmali bauxite mine of Nalco, which is a public sector company, are still rejecting high silica overburden laterites. This is not allowed at present. Similarly, high silica ore, maybe around 8%, 9% ore with 38 to 40% alumina are left behind in the deposit, and they are not being mined. These can be easily avoided by adopting simple beneficiation techniques like dry techniques, and these ores should also be coming to steam. Some observations continues. China, with poor quality of bauxite, is regularly beneficiating their ore by complex flotation techniques. And bauxite of Brazil, Sierra Leone, and Ghana are regularly washed and upgraded. So these countries can afford, why not India? We should also think of using the high silica ores. There is a scope to partly upgrade typical Eastern Ghat bauxite by crushing followed by screening out of mines, which not only decreases kaolinite and goethite contents, but also reduces moisture and improve handling characteristics. So this is not still done on industrial scale, but it is necessary to use slightly higher silica bauxite of this area. A systematic mine plan, great control drilling, generation of internal reference materials, tabletop XRF, use of stacker reclaimer, an online analyzer can help in long-term quality control and provide ore of consistent quality. Some other observations are given here. Since bauxite mining and forest clearance are center subject, a state must not have veto right and stop approved projects. And as for example, in Andhra Pradesh and RAC plant, if the bauxite alumina industry is to grow and compete with the best. So this is what unfortunate thing that Andhra Pradesh government has used veto and stopped the approved projects of NRAC, particularly for supply of bauxite. Plant is running, but bauxite is not available. They are not getting bauxite from this state, which is having about 600 to 700 million tons of high-grade bauxite. Present methodology of calculating average sale price is flawed and rendering bauxite FOB cost at mines to be highest in the world. which is also creating an unnecessary barrier in developing the alumina industry as a standalone like Australia and Brazil. So, for example, OMC is selling bauxite and the average selling price is quite high. An average 45% alumina, 3% silica bauxite of Guinea have FOB price of about $20 per ton, whereas ASP average sale price of Odisha ore is higher than $30 per ton. This should be reasonable, and so that indigenous alumina refinery can purchase and develop their alumina production. Some observations on alumina refining in India. So alumina refinery should have more productive relationship with bauxite mines via regular dialogues and interactions. Because it is observed that sometimes alumina refinery works in isolation with bauxite mines and bauxite deposit. Alumina plants should understand the limitations of mine and its capability, as these are natural ore. And slowly the resources goes down, quality also deteriorates because in the initial years high grade bauxites are exploited and then slowly quality goes down in the deposit. Every year, bauxite mines should be evaluated for sustainable quality and reserves. A geometallurgist can play a crucial role in suggesting appropriate grade for each year for the plant. It is a joint discussion between bauxite mine and alumina refinery, and every year in the start of every year, there should be a quality should be identified that this quality will be supplied for this particular year. With the depleting bauxite quality in the worldwide deposits and mines, local bauxite having around 35% available alumina, particularly for gibbsitic bauxite, and less than 5% reactive silica, should be considered economically viable for low temperature alumina plants because and other plants are using even lower quality available alumina. Observations are continuing for alumina refining in India. Online bauxite analyzer can substantially improve the digestion efficiency. In one of the Chalco plant, there is already installed online analyzer and providing positive results. And the bauxite quality can be checked every 10 minutes, 5 minutes, and that gives a lot of information to alumina refinery to change the solid liquor ratio and other parameters. Similar to financial audit, there should be comprehensive technical audit of alumina production process in each refinery. For example, every 3 months, the feed bauxite, blow-off mud, last washer mud, and mud to pond should be thoroughly analyzed, including detailed quantitative mineralogical analysis to identify undigested phases. Scales in various pipelines should also be studied. These skips will provide a lot of information about the functioning of the plant and improves the production and productivity. Plants should explore digital technologies to monitor and control alumina production by digital twins of production process, which is done very successfully for smelter pots also, and it can be done by the alumina plant also as demonstrated by one of the Rusal plant. Computational fluid dynamics and then machine learning. All these new techniques should be adopted in the alumina plant. Now these observations continued. As silica content is likely to increase in Indian bauxite deposits and mines, it may be useful to consider the ILTD, improved low temperature digestion process. Please refer IBAAS proceedings of 2022 and or Sumitomo differential extraction process. These are all industrial scale. They have done it, and it is time for Indian refinery to consider these new technologies. Over the years, ILTD has been patented in 9 countries by Hungarian process engineers. The process concept has been validated in laboratory, batch experiments, and now one of the Chinese alumina refinery has adopted this process. adopted this process. Red mud utilization must be time bound. Minimum 5 years to start and minimum 80% utilization within 10 years period. So this should be also be made compulsory for alumina plant. Now the main conclusions. So India occupies the 6th position in bauxite production despite having 3 billion tons of resources. India may be in resource position, maybe 4th or 5th million tons of resources in the country. In alumina production, India is distinctly in the 3rd position in the world after China and Australia. With the allocation of 3 large bauxite deposits of Odisha, there may be substantial increase in ore production in coming 1 to 2 years period. And overall quantity may go up to 59 million ton per annum by 2030, provided all these mines comes into stream in coming 1 or 2 years time. So this is the time when there is a rapid development of alumina industry in the country. The installed alumina capacity in the country may rise from present 10.18 million ton per annum to the range of 23 million ton per annum, similar to present production of Australia. It is necessary to use all the subgrade materials of existing bauxite mines while adopting dry and or wet beneficiation processes. All the overburden materials just below the soil, whatever is the overburden materials available, which is high silica and low alumina, interburdens, whatever the non-ore patches are within the bauxite zone, and high silica ore, which is having 8 to 10% silica, but there is a high alumina, 38 to 40%, should be used after upgradation or blended with higher grades. So this should not be left in the mines. So the last series of conclusions, alumina plants should have closer relationship with bauxite mines to understand their problems, and every year a judicious feed grade should be decided, which may be the lower than the previous year, keeping in view the conservation and sustainability of mine. Online bauxite analyzer and adoption of digital twins may significantly increase the production and productivity of alumina plant. As silica content of bauxite feed is likely to increase in India, it is necessary to consider ILTD and or Sumitomo differential process to bring down the caustic consumption and produce usable bauxite residue. Each alumina refinery should provide plan for the safe disposal and utilization of bauxite residue, that is red mud, and minimum 80% should be used within 10 years of period. Thank you very much for your kind attention. I am Ashok Nandi, and we will shortly announce the next conference of IBAAS, which may be held in the state of Goa. Thank you very much for your attention. Thanks and bye. Sorry. Hello. Hello, everybody. Now this presentation is open for discussion. You are welcome to ask question, and we will try to reply your queries. Please.
My name is Wilson. I have
Yes.
a question, and I understand ANRAC has the capacity, alumina capacity production of 1.5 million ton.
Yes.
And I think last year some time ago they started the 750 tons,
Yes.
kilotons of first train. And
Yeah.
how about the second train? Is the second train 750K started up?
Not yet, but they are likely to start within 3 months, 4 months, because they are still facing shortage of consistent imported bauxite. They are getting bauxite from GAC EGA. They are getting bauxite from Ashapura company from Guinea, and now they are also talking to Sierra Leone. So they have to increase the import of bauxite, and they may also get bauxite from Odisha, particularly from Adani Group may provide them bauxite from their first mine, like Balada or some other mines. So they are waiting for actually good contract of bauxite so that they can produce at cheaper rate alumina production, because the imported bauxite is quite costly for them.
Yeah, I agree. Okay, thank you.
Yeah, any more question?
Yes, I'm Das speaking. It was a very good overview of the bauxite alumina scenario in the country.
Yes.
I have just a general question. As you said, the bauxite quality is depleting
Yes.
and silica is on the rise, and overall alumina is going down
Yes.
around 35%. So why no R&D effort is being made to beneficate low grade?
See, everywhere in the world it is being beneficiated, but unfortunately in India, for example, Pachpadmali mine, they just simply avoid this high silica mining of high silica bauxite because they have large resources available in their deposit. But the time has come when they have to upgrade their overburden. There is already reports are available. They can implement this beneficiation of overburden as well as the beneficiation of this high silica materials which is available in the mine. But since they get easy bauxite from their existing mine, they are not seriously trying to implement those beneficiation processes. And unfortunately, no tests have been done so far. But other deposits, they are trying to blend this low grade with high grades, and they are somehow using the whole bauxite. For example, the Bafni bauxite mines, as I know, they are every year they are decreasing the grade so that the total resources increases. So they have a complete plan for systematically decreasing the grade. But unfortunately, other deposit mines, it is not being done so systematically.
No, in the recent IBAAS, I was just seeing a paper by Westech Industries. Mr. BP Misra, he has with their principal in Brazil.
Yes, it's all possible, but that bauxite quality is different. Our bauxite quality is different. So we have to do our own taste, our own things. And there are
but what I understand, this some thickening process they are doing.
No, this is thickening process is there for the tailings. They are whatever tailings comes out in the beneficiation plant. That's a further downstream process. But mainly we have to establish first beneficiation process for our bauxite. Yeah. Any more question, please? Mr. Jadeja is there. Yeah. Any question?
Hello, Ashok. This is Takuo speaking.
Yeah, Takuo, please.
Yeah. And I have one question about Guinea bauxite.
Yes.
Currently, Guinea supplies high quality bauxite with low cost. But do you think that they supply the high quality bauxite in future stably?
Yes. What is one interesting feature in Guinea bauxite? They have quite low silica, around 3%, 2.5%. But alumina goes down. Alumina is many mines now, leftover mines, is having 40 to 41% alumina with 2% silica. So these bauxite suits alumina refinery. but because of low silica. But alumina is going down. And there are examples that 36-38% alumina with 2% silica. And whereas in India, this kind of bauxite is not available. As soon as alumina goes down, silica goes up. So one advantage is there that they have fairly low silica material, bauxite. So it is 40, 42, 44. Average grade is 45% alumina with 3% silica. This is the average grade of Guinea.
So you mean that they have very big mines in Guinea?
Yeah. This is about...
But they are exporting just bauxite. Don't they change their policy to make alumina in Guinea or not?
Good question. See, this is Africa. And basically, if you know Chinese is here, Chinese are exploiting like anything. They are taking 100 million tons of bauxite from that country. And nobody is interested to set up alumina refinery. Government keep telling them, please set up alumina plant, but nobody is interested. First of all, other than bauxite, they don't have anything. There is no caustic soda, there is no power, there is no fuel. Everything has to be imported. Only bauxite is available. There is not a trained manpower, nothing. They have one existing alumina refinery, that is Fria Alumina plant, which is being run by Rusal. But Rusal is not running this plant efficiently. This is producing around 300,000 tons of alumina of very poor quality, 200,000 tons alumina, very poor quality alumina. So it is because of Africa and because of a small country, they are not able to insist to Chinese, as Indonesia has done, that you have to set up alumina plant. Guineans cannot tell Chinese because their economy is dependent on this bauxite export. So it is a sad affair, and they are mining about 105 million tons of bauxite and exporting. Everything is being exported, and exported not only China is the major player, which is taking 99 million tons. Remaining other bauxite goes to the plants in Alcoa plants, in Rio Tinto plants, and in other plants of Europe. So this is unfortunate thing that Guinea is being an African country and developing country is not able to insist for setting up alumina plant.
Thank you. Very unfortunate.
Yes. Any more questions?
This is Santosh Pani here from Indian Bureau of Mines. I want to add one question.
Please.
Regarding the gallium.
Yes.
Regarding the gallium recovery.
Yeah, interesting question. Tell me.
So is it currently whether NALCO or any other companies are doing, as per our record, NALCO is doing the gallium recovery. So
no, nobody is recovering gallium at present. Okay. And actually this gallium slowly gets concentrated in the liquor. The plant becomes old and the gallium gets enriched in the liquor. And that is the time you have to start extracting gallium. Actually, gallium content in Eastern Ghat bauxite is not so high. Central Indian bauxites are having more gallium. In the Balco, there was quite...
It is concentrated in the gibbsite. Gallium
is in liquor, because when you are digesting bauxite with caustic soda, and this caustic soda solution, they get enriched with the galliums continuously when you are using for 10 years, 20 years. Bauxite is extracted from bauxite and gallium gets concentrated in the plant liquor. Because plant liquor keeps circulating in the whole system. Yes. And every year, plant becomes older and you can extract gallium. Now, Hindalco is very seriously considering to extract gallium. They are working with some companies in Japan. Takuo Harato is here. He knows about the things. No. And they are talking to Japanese for extraction of gallium from the plant in Renukut plant. But still, there is no success. Vanadium is extracted regularly in the form of V2O5, but V2O5 has low value and they just sell it.
Okay.
Unfortunately, none of the alumina plant has done serious work on gallium extraction.
And about beneficiation also, I want to add one more comment that the Indian miners they are not serious about beneficiation. We did lots of tests in our lab.
I know.
And moreover, the concern is about the reactive silica. The silica is
Yes.
not the total. You have mentioned the total silica. The problem is arises with the reactive silica, about the kaolinite.
When total silica is reduced, automatically it is kaolinite, which is reactive silica, which goes down. And you can see some of our papers. If you are interested, just send me one email and we'll send you some good papers on bauxite beneficiation.
Yes. We are doing that. We are also did the research.
Yeah, I know. But Eastern Ghats bauxite, there is not much work done.
Yes.
You have to do work on the Odisha bauxite.
Yes. Now, and that gallium content, I want to add more comment. Gallium content, we did the EPMA study, and gallium it was found in the gibbsite structure of the gibbsite only.
Now that is occurrence of gallium in
Occurrence of
bauxite.
gallium.
That is true, but extraction is done in the refinery from the plant liquor.
Yes. Till now, nobody is doing the gas
No,
extraction.
India, nobody is doing, unfortunately. But Hindalco is very seriously working on this with Japanese.
Okay.
Any more question?
Hello,
Yes.
myself Bharat Binde. We are interested to beneficiate Kutch bauxite, which is having 45% Al2O3. So, is there any agencies are available? Is my first question. And second question is, we have got also kaolin mining lease, in which we find 38% of Al2O3. Can it be beneficiated?
Okay, to your first question, Kutch bauxite.
Yes.
Unfortunately, in this Kutch bauxite, you want to make a plant grade, no? From 45%, you want to take it to 55 or 60%, no?
Yes, correct.
Yeah, for this, you have to remove the iron content. And unfortunately, iron content cannot be removed without grinding bauxite. If you can afford to grind bauxite to very fine size, you can go for high intensity wet magnetic separation, and part of the iron can be removed. But this iron will then add up into the alumina and you can go up to 50, 55. But this is quite a costly process. Some tests have been done in different bauxite of the world and iron can be removed. But it has to be, you have to ground very fine because liberation of iron doesn't take place as such ore. So for Kutch bauxite, you have to carry out some tests and experiments in either in IBM or IIM, Bhubaneswar R&D Center. We can help you and we can guide you how it can be done. But you have to remove iron or also remove calcium oxide, CaO. So we have done a lot of tests on Eastern Ghats bauxite in Odisha bauxite, and we could reduce iron content from 24% to 9%. But below 9%, you have to do little acid leaching. So there are processes are available. You have to reduce the iron content, and that requires a fine grinding of bauxite. Can you afford that kind of grinding and wet magnetic separation? This is a costly process. It's not a cheap one.
Okay, and the second question, on the continuous question, can it be separated through spiral heavy gravity separation?
No. Gibbsite, bohemite, and hematite, almost they are in the same specific gravity. These minerals are very difficult to separate. You can separate it by some flotation, but also not very successful for Indian bauxite. You have to do high intensity wet magnetic separation, then acid leaching. That is the way we have found that iron and CaO can be brought down. You need iron content 4% for your plant grade bauxite.
Sir,
So-
I want to add one question, one comment. They can send the bauxite to IBM. We can study the spiral concentrator, which was they saying.
Spiral, you will not be successful
No,
because
no. We have to study the characterization, what the mineral
Yeah,
present.
that
We have
is
to study.
different
If it
thing.
is,
You have to study those things. The IBM person is here, Indian Bureau of
Okay.
Mines, Mr. Santosh Pani. He can provide his email address, and our office may be having, and we can give you email address, and we can coordinate this work, whether it is feasible or not.
Okay.
And kaolinite, this is very interesting thing. Actually, nowadays in many countries, clay is used for making high purity alumina, which is having quite a good value. And this Canadian have developed this technology, acid leaching technology, and you can directly make high purity alumina from clay, which is the high alumina clay. So these technologies are available, and Australians and as well as Canadians are planning to set up a plant for high purity alumina, which is having very great demand in the world market. So you can send the composition of this kaolinite, and we can suggest you what you can do out of this.
Okay, thank you.
Any more question? Hello, any more question? So thank you very much for your participation, and you will hear from IBAAS office about the next lecture of this series. And if anybody is interested to present any paper in this IBAAS platform, they are welcome. Please contact our IBAAS office, and the paper should be of general topic, so that is of general interest for everybody. So please indicate if you are interested to present any paper. Thank you very much. Thank you for participation. If you need anything more, please let us know.
Thank you. Thank you.
Thanks.
Thank you.
Thanks. See you then.
thank you.